In this lesson, we are going to take a look at graphing linear equations. But before we can know what to do with them and learn about how to use them, we have to know what they look like. So the first question we have to answer is, what makes an equation linear? An equation is linear if we can check two boxes. The graph of a linear equation, if you look at the name of it, it'll tell you what it looks like. It looks like a line. The catch is this has to be a straight line. It can go up. You go down. It could be horizontal. It could be vertical. There's no turns, there's no twists, there's no sharp curves, one straight line. As far as an equation goes, an equation would look like y equals mx plus b. This is what we call slope-intercept form. But the big thing here is for you to notice the exponent on the x. That x has a 1 as an exponent. No, math people are lazy. Math people are very lazy. We like to take shortcuts. And so if you see an equation or an x or a y or a z or whatever that doesn't have an exponent, it looks like we forgot to put it. We didn't forget. We just don't write it when it's a 1. If you have an equation that looks like 3x minus 4, it doesn't look like there's an exponent up there, but it's a little imaginary 1. And as long as that exponent is a 1, it's a linear equation. If we had x squared plus 3x equals y, our biggest exponent is a 2. So this is not a linear function. When we put those two ideas together, we get a linear equation. So this is a relationship between two variables that changes at a constant rate. And this constant rate gives us the straight line and the exponent of 1 on the x. So those two things combined give us a linear equation. Now, one of the things you'll be asked to do is to decide if a point, and when I say point, I mean an ordered pair, is on a line. So here's how you're going to tell. If the point, or if a point is on a line, then it is a solution to the equation. Well, that definition is great, except it doesn't tell you what to do. So let's change this into English instead of math. When we use the word solution, here's what we mean. This means when you substitute for x and y, so when we take our ordered pair and we substitute for the x and the y, the math works. That's the English version of what it means to be a point on a line and for that point to be a solution to the equation. So let's try it. We want to decide whether each of these ordered pairs is a point on the graph of this line. All we know so far is that it has an exponent of 1 on the x, so it's linear. But in order to determine whether each of these ordered pairs is a solution, we start out by writing the equation. For part A, I'm going to leave a hole for the y and a hole for the x. I'm going to plug the -1 in the x spot. I'm going to plug the -5 in the y spot. So I get -5 is equal to, I know 3 times -1 is -3. I get -5 equal to -5. This is a true statement. So A is a solution. And I've got the same equation, a new point. So I'm going to use the version of my equation that had a hole for the x and a hole for the y. This time my x is a 1. My y is a 1. So I get 1 is equal to 3 minus 2. 3 minus 2 is not -1. I was testing to see if you were paying attention. 3 minus 2 is actually 1. And 1, last time I checked, was actually equal to 1. Since that math works, 1, 1 is a solution. So we'll check 2, 5 last. I'm going to set up my holes. And then I'm going to fill in the holes. 2 goes in the x spot. 5 goes in the y spot. I get 5. 3 times 2 is 6. Now, y'all, last time I checked, 5 was definitely not equal to 4. So this is not a solution. So every time we get a solution, it's on the line. So -1, -5 is on the line. 1, 1 is on the line. But 2, 5 is not on the line. That means it's floating off in space somewhere. Now let's follow a similar process to turn our equation, this y equals -2x plus 1, into a graph. the first couple of times we do this, we're going to use what's called a t-table. And a t-table is a way to take x values and turn them into a y value. Our x values are generally what we call our input values. And our y's are generally our output values. So what I'm going to do is I'm going to pick some x's. It doesn't really matter what we pick. Usually when we graph a line, we try to graph at least 3, maybe 4 points. So I'm going to do -3, 0, 3, and 6. Do I have to pick those? No, I could pick totally different points and it would all be fine. Here's my process. Just like when we tested points to see if they were on the line, we're going to take our x values and plug them into the x spot in our equation. Then we're going to do the math. So if I start with -2 times -3, well, that's +6. When I add 1, I get 7. So my y value is 7. And that means on my graph, I'm going to graph the point -3, 7. This time, I'm going to plug in the 0. -2 times 0 is 0. Plus 1 is 1. So I need the point 0, 1. I'm going to plug in the 3. Now this is something you could totally do in Desmos. You could plug in -2 times 3 in the calculator and add 1. If you really are not comfortable with positive and negative numbers, absolutely feel free to go and utilize the tools you have available to you. I do recommend that you get a lot of practice in on the devices that are allowed on your exams. So if you are a person who likes to use the calculator on your phone, I'm going to highly recommend that you get used to using Desmos because that's what's allowed on our campus in our department. Our last point is 6. I'm going to be consistent with my colors. So we filled out our table. We're going to pick 2 points. The geometrical idea of a line is that a line contains at least 2 points. So I'm going to choose the easier ones to graph. I think I'm going to pick 0, 1, and maybe 3, -5. 0, 1, so 0 on the x, 1 on the y, and 3 on the x, 1, 2, 3, 4, -5 on the y, and then we attempt to connect them with a straight line. And if you don't get it right through the middle, it's okay. So there's a line. Same idea here. I threw this one here because we have a fraction, and fractions tend to be a little bit scary. But what we're going to do is we're going to choose our x values so that the math with the fraction isn't so bad. Since my denominator is an even number, I'm going to pick x values that are all divisible by 2. That's going to make the math easier. So I'm going to plug in my -2. 1/2 of -2 is -1. Minus 3 gives me a -4. I love doing math with zeros because half of 0 is just 0. Half of +2 is 1. Minus 3 is -2. Half of 4 is 2. Minus 3 is -1. So my points would look like -2, -4, 0, -3, 2, -2, and 4, -1. So we pick 2 points from the table. Make your life easy. Pick some that are easy to graph. I'm going to go with 0, -3, and 4, -1. If you don't like those points, if for some reason you have something against 0, -3, and 4, -1, you can pick the other 2 points. It's totally fine. 0, -3, 4, -1, and I connect the dots the best I can. So there's the equation of the line written or drawn using the equation y equals 1/2 x minus 3. Now, if you look at the equations, right here, I have a +1. And my graph crosses the y-axis, or y equals 1. For the second one, I have a -3 in the back. And my graph crosses the y-axis at -3. That's not a coincidence, folks. That means that when we start writing the equations of lines, this number, our y-intercept, is going to be that last number in our equation. But for now, let's graph another line. We have the y-intercept. Remember that the y-intercept is where the graph crosses the y-axis. So my y-intercept is 0, 4. That means I'm going to start at 0 and go up 4. 1, 2, 3, 4. Now my slope is -3. When we talked about slope before, or -3/2. When we talked before, we said that meant my rise was -3, so I'm going to go down 3 and to the right 2, because we always run to the right. So I'm going to go down 3, 1, 2, 3, and I'm going to run 1, 2, and put my other dot. Then I connect them. Close enough. And there's the equation of the line. If you have additional questions about anything that's in here, please absolutely feel free to send an email to your professor. They will be happy to give you some more information.